Okay, folks, I've done this about 300 times and it's getting really tiring now. I'm gonna try my best to do it in one take. Okay, so this is called homogeneous second differential equations, and this is what we're solving for. Okay, homogeneous means it equals zero. Now, um, I'm gonna go through the rules first. Okay, the rules. Okay, so we have something called roots, and the type of roots that you get comes with its own solutions. Okay? So if the roots are the same, okay, the solution is bracket ax plus b e to the ax. Okay? And if the solution is different, okay, the solution is a e ax plus b e bx. These are small a and b on the top of the e on purpose. Okay. See, if the roots are complex, okay, then automatically the solution is complex, and what you get is e ax bracket a cos beta x plus b sine beta x. Okay, but don't worry about this one specifically. We're going to tackle these two. Okay. Now, write these down. This is important. They don't make sense right now, which is cool. It's normal. We're gonna make sense of it in the next slide. All right. So first example that we're gonna go through, all right, is one where the roots are going to be the same, which is the first rule I explained on that last slide. All right. So for this question, we're gonna have dy dx squared. So this is notation for second differentials. Okay. Minus 10 dy dx plus 25 y equals 0. This will always be the format, alright? So you'll always get, okay, you always need this first part. The second differential annotation needs to be there. You can have it without the rest of it, and you can still kind of solve it this way. But you can't do without that first part. This part is essential to it. Okay? Now, the first rule, alright, we need to change the format. The first step, okay, we need to change the format. And basically, we're going to change anything with a differential sign, we're going to replace it with the letter m. Okay? So there's a differential sign here, so m minus 10m plus 25. 25 has no differential sign, so we just take it down as 25. Now, this differential is of a second order, and that one is of a first. So they can't be the same, can they? So that's why this is m squared, and that's just m. Alright? And keep in mind, there's a 1 here. You can't see it, so it's a 1. There's a 1 there. Okay? And all of this equals 0. Now the second step, alright, we need to factorize this. Alright? This is how we get our roots. Alright? And what we need is two numbers when we multiply give me 25, and when I add give me 10. Okay? And well, there's only two numbers that can multiply to give you 25 is 5, and they need to be negative to give you positive, and when you add them they give you negative 10. And so the solution is m equals 5 and m equals 5. These roots are the same. Okay? Following the rule that I used in the last slide, the solution to these roots, because they're the same, will follow ax plus b e ax. If I'm not mistaken, but I make mistakes, so I'm just double checking. Yeah, eax. eax. Okay? Where a, so if we just look, where's my cursor? This letter here, that small a, is the only thing we'll be changing. Alright? So our answer is y equals ax, it's a bracket, plus b e and the solution was 5x. Okay, done. Now, there's a few things I need you guys to notice, and girls. Where's my cursor? Alright, this is y only because the original differential equations were y's. Okay? And there's x's here and here only because you were differentiating in terms of x from the very get-go. Okay? So if it was dz over dt, okay, your equation would equal, well, your equation would be z equals at plus b eat. Understandable? So it's not always y and it's not always x. You have to be wary of what letters you're going to put in. Okay? So again, as long as we're following the steps, all we're going to do is follow the same steps from the very get-go. You're given this equation, change it into this format, and then factorize. Okay? Let's do another example. Alright, the other example. Okay, so this example here, alright, is d2y over, come on, come on. And you know what? That means start from the start. Okay, so dy, okay, it might seem like I'm rushing this, but this is take 5 million. Okay, so you know, you can't believe how many mistakes I made, and then I just end up swearing, and then the whole thing just goes to hell. So anyway, alright, so just so you know, the coefficients here are 1 and 1. You can't see them, meaning they're 1. Now, I'm going to add an extra part to this question. Alright, I'm going to say when x is 0, alright, y is 5, and dy dx is 3. Alright, but we're going to solve this at the end. Just make note of it, okay? So, the first thing we always do is write the notation out, okay? This becomes m squared, that becomes m, and that just becomes 20, okay? M replaces the differential sign, okay? And that one at the start is m squared because that's differentiation, that's the second order differential. Alright, step 2, factorize. So, let's factorize this thing. So I need two numbers. When I multiply, give me 20, and when I add, give me 1. Well, plus 5 and minus 4. 5 times 4 is 20. When I add them, I get 1. Remember, this is 1 here and 1 there. Okay, so my solutions are negative 5 and positive 4. Okay, these roots are different. Alright, so the solution to these roots are, well, will be ax plus bx. Okay, where, so now our answer will be y, okay, equals ae minus 5, because that's the first root, plus, to be fair, it doesn't really matter where you put it, it'll be consistent regardless, be 4x. Okay, there's an x here. What I meant by there, it doesn't matter if you put minus 5 here or here, just as long as you're consistent with where you're putting things. But it's fine for you guys, it's fine, just continue on. Okay, anyways, so we've solved the actual, so this is the solution to the question. Alright, this is the question solved. Okay, but there's an extra part that we have to deal with, and I'm going to do it in the next slide. Okay, so the answer we got was y equals ae minus 5x plus be 4x, and the question says, well, when x is 0, okay, y is 5 and dy dx is 3. Okay, now it might not look like it, but two things are happening here. Okay, it's technically what it's saying. All right, when x is 0, y equals 5. That's one thing. Okay, that's just on its own one thing. And then it's saying when x is 0, dy dx equals 3. That's another thing. All right, so this is 1, and that's 2. There's two things happening here. All right, we're going to solve the first one. All right, so when x is 0, y equals 5. All right, well, it's not hard what we have to do here. We're going to literally replace this. What the hell? All right, sorry. Leave. I don't know what's going on. Oh, I don't want to do this again. Come on, just cancel. Just go back to how you were. It's perfect, it's perfect, it's perfect, it's perfect. Jesus. Okay, so what? Yeah, okay. So what we're going to do is we're going to literally replace this. So this was our solution. Okay, we're replacing this y with the number 5, and replacing the x's in the solution with the number 0. Okay, because that's what it tells us to do. All right. So I'm gonna just find my cursor. All right. So the equation was this. Okay, and I'm going to place 5 as y and x as 0. Okay, and well, e to the power of, well, minus 5 times 0 is 0, and e to the power of 0, anything to the power of 0 is 1. So I'm just going to get a times 1, which is just ea. Plus, the same thing happens here. 4 times 0 is 0. E to the power of 0 is 1. 1 times b is b. There we go. Our solution is there. 5 equals a plus b. That's it. That's ticked off for this first part. Okay? Now the second part's a bit more, it's a bit more, okay? I'm just going to do that in a second. No. Alright, so the answer we got was y equals a, it was x, right? Yeah, no, it wasn't Chapman. Minus 5x plus b e 4x, okay? And then I said when x is 0, dy dx is 3. Well, in this equation, we have y. We don't have dy dx. We have y. So we're going to need to differentiate, all right? And to differentiate this, okay, well, what happens is the rule, well, dy dx, okay? The rule for exponentials is that you just multiply the number at the top and to the front. So you have minus 5a e minus 5x plus 4b 4x. Okay, you've differentiated it here. Okay, now I can apply these two things into this equation. I can replace this with 3. Okay, and I can place x as 0 now. Okay, and what I'm going to get is, well, again, this is going to give me 1, so minus 5a plus 4b because, oops, that is going to give me 1. Okay, and that's my solution. I have then solved it for that. I've hit all the criteria. I've done the first part where it told me when x is 0, y equals 5, we solved that. And when it said x is 0 and dy dx equals 3, we've just solved that. And from the get-go, we solved a homogeneous second-order differential. Alright, this was take 5000, so I apologize if it was a bit slow. Like and subscribe, hit the bell notification, all of that lovely stuff. Peace out. Alright, stop. Okay, any second now, recording will stop. Jesus Christ, man. Okay, don't fuck up now. Oh, I just did. Save, man. Save, save, save.